It takes appropriately communicating parts to make a system work. For HVAC, that's air terminals and pieces of mechanical equipment connected by ducts and pipe networks. Interestingly, Revit has a set of tools to ensure duct and pipe systems are appropriately connected both physically and logically. In this video, we'll analyze our model using the check system tools in Revit. So start by opening the file you used in the previous video or check systems in the chapter 4 exercise files folder. So at this point, launch Revit. I'm going to exercise files from the chapter 4 folder. Open this file, check systems, which I have here open. Then open the ground floor HVAC plan, which I have here. We'll explore the tools in the check systems panel of the analyze ribbon. So click the show disconnects button. Then check ducts and pipe in the following dialog. Then click OK to close it. Now you see some warnings. Now when you open the system browser or you right click and check system browser, you'll find some unassigned connectors here. So you can see some under mechanical, some under piping, and some under electrical. Now when it comes to HVAC, these are primarily connectors with no connected pipes or ducts yet, and the show disconnects to with flag such connectors. So in this scenario, you have three options. First, you can create pipes or ducts out of the connectors. So a good example is the condensate pipes in the fan coil unit. So for example, we have these fan coil units, and what is flagging is the condensate pipe that's supposed to come out of here. In our projects, we choose not to model that just yet, but this is one. So from here, I can just activate this pipe connector and I draw a pipe out of this place. The moment I draw a pipe out of this place, you notice that will actually disconnect. But I guess sanitary pipes are not visible in this video, that's why it's not visible. But that's to show you that's one of the solutions that we have. So you can see that it disappears. I'll just undo that. Once I undo that, you see that it comes back. So that's one option. The second option you have is that you can open the family and you can remove the unused connectors, because you won't always use all the connectors in your project's HVAC components. So for example, we have this boiler equipment here. So when you look at this, it's flagging two unused connectors, one for the exhaust air and one for another type of pipe, probably a condensate pipe. So I can open this family knowing that I'm not going to use those pipes in this project. I can just edit the family and I delete the pipes just to reduce the warnings in my project. So this is the one for the exhaust air. Check the system classification, you see that it's exhaust air. So I can just delete this connector, select this other one here, which is probably for condensate pipe. So you can see, okay, say gas in, and you can see that system classification is other. And I know that I'm not going to use this in my project. I can as well delete this. So I've used these two already. So I can just load this back into the project and override the one I have. Make sure you override only the component and not the parameters. So I just select this and you notice that those two or the four warnings altogether have disappeared. Now, thirdly, you can ignore the flags that don't impact your project negatively. So for these other ones, you can choose to leave them. Of course, I can still open this one and delete the ones I don't want, but that's basically the third option. You can just ignore it for now. So when you look at this system browser, you see that we have 34 unassigned connectors and 13 has to do with the HVAC systems, while I have 21 that have to do with electrical connectors. So these are power connectors, and what that means is that there are 21 powered components in this project, all yet to be powered. So we're not going to power them in this project or in this course. So if you want to learn more about powering components, you can check out my other course, Revit for System Design and Smart Buildings. So that's the first part of this show disconnects to, but the show disconnects to doesn't always flag only unused connectors. Sometimes it can also flag physical disconnect in your ducts or pipe layouts. So let's say, for example, I come to this place and I delete this from, let's say mistakenly during design, something happened and you mistakenly deleted. So this can easily review when you have disconnects. So this is another way that you can use this tool. So you can always use the trim tools, or you can fill in the gap with a pipe or duct. Depending on the scenario, you can always correct whatever disconnects you have in that place. Then you can also have some scenarios where it flags ducts or pipes that have open end. So let's say, for example, I need to extend this duct all the way to this place. So I can convert this to a T, and then I create a similar duct, and then I extend this to this place, and then I forgot to close it up. So when you have scenarios like this, when you select a pipe that is unclosed or duct, you find this cap open ends to here. So when you click on this, it will actually close up that open. So let's say that's where the duct or pipe, and then there are some designs you have ducts or pipes like this and it's still open. So you can always select the duct or pipe and you can cap open end. So that's also another use of this tool. So for now, we'll go back to the analyze ribbon and we will uncheck this duct and pipe and close the dialog. So you have 3 other tools here, and the other 3 tools are specific to duct, pipe, and electrical systems. So we'll look at the duct and pipe. So let's start with the duct systems. So when you click on this, it's supposed to show you the issues you have within your duct system. So currently it doesn't show any warnings, and that's because it has not identified any critical issues in the supply and return air system. You can also check the first floor and see if it flags any issue. So this is because we've taken our time to make sure that everything is physically connected, both physically and logically. Everything is properly connected. So just to show you, if I also delete maybe one of these components here, and then I check this, you notice that it will immediately flag this as an issue. When I click on the flag, you see what it says: elements are not connected in a single physical network and whatnot. So depending on the scenario, these tools can reveal issues that I have within your design that you might not easily identify. So in the course of design, you might make some of this identifying it. So through these tools, you can always find them out and fix them. So we'll move to the next tool, which is the check pipe systems. So I will make sure that this one is unchecked, and then I check pipe systems. Now you can see that this one reviews a whole lot of issues. So if you closely investigate, we'll just click on one of these, and then you see that what it says: the calculation was run with the pressure drop set to 0. So most of these warnings have to do with the pressure drop values of our components, and that's because we've actually not configured the pressure drop. We just created the families and we've not inputted the pressure drop values. So typically manufacturers specify the pressure drops in their catalogs. So what we'll do is we'll begin to assign this. So let's say we select this. Depending on how the family was created, this could be a type parameter or instance parameter. In this one, we know that it's a type parameter. So when you click on edit type here, and then you come here, you see the pressure drop value. So I can type in a value of say 14 pascals. So depending on the manufacturer and their specifications, this value can differ. So I'll fill in this 14 pascals, and you notice that it will now recalculate the pressure drop in that system using that value, and that error will disappear. We'll do the same for the return. We'll select this edit type, and we'll also fill in the same 14 pascals. Again, this can differ on your project depending on the project specifications and the manufacturers they are using. So now we have the fan coil units left. You can see that this has reduced drastically. So for the fan coil unit, we have 3 different pressure drop values, or things that have to do with pressure drop. So when you click on edit type here, you find the pressure drop for cooling and pressure drop for heating. So in this project, we assume that we are using 13,000 pascals or 13 kilopascals for the cooling, and 7,000 pascals or 7 kilopascals for the heating end of the coil or the water flow systems. So now we still have one warning left, and that's because we still have the external static pressure. So that actually differs for each zone. So that's why we created it with an instance parameter here. So now for us to fix this, we will need to use the system inspector tool to inspect the system. That's actually the focus of the next video, but for now we'll quickly do that. So to do that, we select this fan coil unit, and you click on System Inspector. Then you select the supply system because it will have more pressure than the return. And then we'll use the inspect tool here to hover over our fan coil unit. So from here, you will note the value. You can see the static pressure, which is currently 126.7 pascals. So you note this value, and then you select this component and you fill in that value here, which is 126.7 pascals. So you click on finish. So basically you will do this for the remaining fan coil units. So I'll quickly do that. So this should resolve all the issues in the duct and pipe system. You can see we don't have anything left on the ground floor in the entire system and nothing left on the first floor as well. Now, another related tool that reviews issues in a project is the warnings tool. So when you select a component, for example, when I select this flexible duct here, you will see this show related warnings if there's a warning related to that particular item. So if you want to see where all these warnings in a project lie, you can go to the manage ribbon. Then from the inquiry panel here, you will see the review warnings in the project. So when you click on this button, you will see all the warnings in the project. And now you can see that there are other 22 ducts. There are 23 ducts in this project in total that have a similar issue. And the reason is because the specified maximum duct length, flexible duct length in this project is 900, and each of them are more than that length. So in this case, you have two solutions. The first solution is for us to modify this layout and make sure that this duct does not exceed 900. When you select a duct, you will see the length from the properties. You can see this is 1013. So now the way we can fix this is I can delete this flexible duct. I can delete it and also delete this transition. Then I can bring this duct closer to the fan coil unit. Also, sometimes I have to tap tab so you don't select the fan coil unit. Although this is quite too close, but now I can activate the flexible duct command. You can type FD. Then I make sure that this is supply. I make sure that the system type is correct, supply air. And now I can complete this connection with a shorter flexible duct. So now when I go back to this place, you see that this is no longer 23, it's now 22. So I can keep tracing each of them. For example, when I select this, I can show where this actual duct, flexible duct, is in the project to take me straight to that place. It can even open the view if it's not open. So you can see I can select this and fix it up. So I have to connect a pipe to stop somewhere here and I complete it. So that's how you can keep tracing it. So that's one solution. The second solution is for you to now increase your maximum flexible duct length for your project. So when you go to your mechanical settings from the manage ribbon, you go to your MEP settings, then mechanical settings, then under duct settings you see conversion. So this is where you specify that value, maximum flexible duct length for both your supply air and return air. Now this solution is not always the best. Depending on the project specifications, you might not want to go beyond a particular value. So a more ideal solution is for you to manually reconfigure your layout and make sure that none of that flexible ducts go beyond what is specified in the project. So now you can see that the check system tools in Revit reveal flaws to designers and modelers that they might not easily see. So now you can use these tools to investigate your designs and identify and resolve issues. In the following video, we'll look at the system inspection tool in more detail.